I'll be talking about IIIF, and then Sasha will be talking about IIIF. We tried to coordinate our talks, so I'm going to try and stay at a fairly high level, though I'll be showing applications. And then Sasha's examples will take you into the nitty-gritty of the application they're developing at Canadiana. So we hope the two will mesh reasonably well. And we thought we would hold questions till the end, since probably the questions that come out of my talk will be answered in Sasha's talk, so we can be more efficient that way. IIIF, and that is the official pronunciation, I believe, it came along about 5 years ago, 2012, written on the back of a napkin in a restaurant in Palo Alto at a meeting of Stanford and Bodleian Library, I think, and Bibliothèque Nationale techies. I heard about it, I suppose, a few years after that, and thought, oh yeah, that's that new tiled image serving protocol. I should probably get to know something about that when we're ready to move our image tiling system up to the next level. But there is so much more to IIIF than that. It provides above the tiled image level, there's the whole presentation level. So it provides a book reader the way you're used to on Internet Archive. But above that, the manifest itself is a lovely structured package of information about a digitized object that can be reused for other purposes. And if you take nothing else away from my talk, I hope that you'll retain that idea that there's multiple levels here and that it's useful far beyond the eye candy that I'm going to be showing. Lovely as the eye candy is. So that is, trying to stay on the mic here. So that is the site, IIIF.io. It's a very well-maintained site, good up-to-date documentation, lots of links to projects and applications. If you're interested in IIIF, you'll learn 90% of what you want to know on that site. There are about 100 participating institutions who have either implemented or are taking part in the IIIF community, including big names like the ones I mentioned, like Internet Archive and so on. Beyond this site, there's also their GitHub repository, which is GitHub/IIIF. And it's worth having a look at one repository within their organization, which is called Awesome IIIF, Awesome-IIIF, and that's the community-maintained list of resources and demos and links and so on of all sorts. Again, that's where you'll get the good stuff. So the goals, it's worth having a reasonably close look at these. So the goals that the organization has set for itself to provide an unprecedented level of uniform and rich access to image-based resources for scholars. So that's explicit within the goals of the organization. That doesn't mean that others aren't welcome, but just that the level of functionality they aim to provide should support the needs of scholars in working with digitized resources. They do this by defining APIs that support interoperability between repositories, and that's where we get into that idea of a rich package that can be reused. It's not just something that drives my website, it's something that can be harvested and reused for other purposes. And to provide a world-class user experience in viewing, comparing, manipulating, and annotating images. And I think the last of those, annotating, is the really exciting part. And a very nicely thought out API to use the open annotation specification to allow users to create annotations for the images that you present to them and let them view. So it's, as I say, a family of APIs. The image level one does the tiling. Sorry, everyone knows what I mean by that, right? Like the Google Maps effect of being able to give you an infinitely deep zoom into an image, not by downloading very large images to display in the browser, but by, as you click in deeper and deeper, you get more and more detailed tiles cut from the image that fit together. So you can get that deep zoom without using all your network traffic to download a huge image all at once. So the image API allows for that. The presentation API is, I think, the most interesting, has the most impact. That provides a metadata package with all of the structural metadata about the item you're presenting, all the pages of a book, whatever you're giving it. It can link to descriptive metadata. It can embed some descriptive metadata, but only in name-value pairs as labels, and this is explicitly intended not to be a metadata standard. You should not be doing structured metadata here. This is just for the convenience of displaying something to the user. Real metadata lives elsewhere. The search and authentication APIs are the most recent additions to the family. Search API is intended to allow you to drive a full-text search of a book or document that you're presenting in IIIF based on a server-side image, a server-side index. So you can have a Solr index of the full text of all your books, and the IIIF client can run queries against it to find occurrences of given terms within the book that the user is viewing. It's also possible to do full text search against included annotations, but we will pass over that. And the authentication API is for those who have the requirement to authenticate access to the images, to the tiles in their collection. And Sasha will have an example of that from Canadiana. All of these APIs are based on JSON LD, which is the JSON representation of linked data. So it's RDF mapped into a JSON format, which is the JavaScript based data format. And that is how, I think that's one of the most promising parts of IIIF, the fact that every time you're presenting something like a book through a IIIF interface, you're creating linked data. And the identifiers that are used internally by your IIIF client to present the pages in the right order are URIs and are available for use beyond the confines of your IIIF system, and they're available to be used as URIs for further linked data applications. I got to remember that turning my pages doesn't turn your page. Come on, there. So we'll start down at the tiled image layer, and just to show the care with which the specification has been thought out, I think, and the flexibility it gives you. To get a tile off of an image, you need to build a URL with 5 elements appended to the identifier of the image you want. So you tell it the region, the size, the rotation, the quality, and the format. So the region lets you crop out a particular area of an image. So you don't have to deal with the full page image at once. You can use IIIF to zoom in on a particular area. You can tell it the size of tile you want. In this case, the 1024 comma means I want it to be 1024 wide, and however high makes sense to go with that, normally 1024. Rotation in degrees. The quality, in this case, default is what the server likes to give you. I'll get into the details of that. And the format, I want a JPEG image. So the options here, in addition to these fully specified things like those precise pixel coordinates of the rectangle I'm trying to extract, I can also just say full, give me the full image. And for, if it's supported by the server, I can ask for a square thumbnail if I'm driving an interface that likes to have square thumbnails. Likewise with size, I can ask for full. For quality, the normal options are color, gray, bitonal, and then whichever the server treats as default out of those. And the major image formats are supported for format, with JPEG being the normal default. And as it creates the tile that you've asked for with an URL like this, normally it will apply these operations in the order they're listed here. So it will crop out the part you want first, resize it, rotate it, and then render it in the quality and format that you've asked for. So obviously, you're not often going to be making these by hand, though if you need that, if you really want, I want a JPEG of this section of this image, this is a handy way to get it. But normally it'll be a JavaScript client running in your browser that will be composing these requests to get the tiles you need and display them. So a couple of examples to hammer Princeton's server. So here I'm pointing at a leaf of an incunabulum, I think, at Princeton. So I'm asking for full size, full region, full size, 0 rotation, default.jpg. And actually, yeah, these are preloaded in the other window. Sorry, I have not used Windows in so long that I don't remember how to get out of full screen and into another. Okay, so that now so it's in the background here. Right, okay, so here's what Princeton sends us. So this is a very, very large JPEG. That's why it's loading like that. But Princeton doesn't mind. They're happy to render very large JPEGs off their JPEG 2000s all day long because they offer it as a IIIF service, and they didn't block me from making requests like that, as they could have in the API. So if I go back, yeah, so that shows the resolution that Princeton is willing to offer us. We're zoomed right in on this page. If I go back and get to the, actually, I'll talk through the URL first. Sorry. Here. So now my next URL changes that, so we ask for a particular odd rectangle from this image. We want a tile 256 pixels wide. We want to rotate it 45 degrees, and we want it in grayscale for no good reason. And Princeton happily obliges. So here it is, just as I asked for it. I've used this example in other presentations, and Princeton might be starting to wonder why people like this rectangle quite so much, but that's their problem. So I hope that shows the strength and flexibility of the. I keep losing the background. Why can't I get back to where I am in the slideshow? Okay, I do that, and then it's in the background there. This whole digital thing, who thought of this? Okay, I'm gonna. So that shows the strength and flexibility that this API allows if you're willing to put the processing power behind it to meet requests like I just made. All of the information that a IIIF client, which is a JavaScript application normally, all the information it needs to determine what it should ask for to meet a particular purpose is encapsulated in a file conventionally called info.json. There will be one of those for each image in your collection. It might be generated on the fly, or you might do it statically. And you can see that it tells the application what the options are. So on the right-hand side, the qualities and formats, if the one you wanted isn't on that list, then you know there's no point asking for it. And the supports has a much longer list of possible values of specific bits of functionality that are offered by this server. So again, the client always knows what the server can do, and it's up to the client to make requests that the server can actually serve based on these menus of options. And as I said, this is linked data. So if you can read that, the attribute height 7200, which you would find in the JSON, in that info.json telling you how big this image is when unpacked into linked data, is a triple. The subject is the image this came from. So again, we're still on that Princeton image. And that is therefore the URI for that image. And the predicate, in this case, got pulled out of the IIIF vocabulary, which has the right fields we want for describing image properties, in this case height. And the object is expressed as an integer according to the XML schema that RDF uses for these things. So even though it looks like JSON is reasonably concise, much more so than lots of other RDF serializations, it is full linked data, full RDF. And that is a good thing. Can you hear me when I'm talking this way? I feel like I'm getting away from the mic. So, got ahead of myself there. Oh, and sorry, I was going to go back. Missed this one. Obviously, there are a very large number of options available. I've only shown you a handful of them on this slide. And IIIF allows for simplifying the environment that the client has to deal with by specifying levels of compliance with the standard. There are 3 levels, 0, 1, and 2. And 1 and 2 represent slightly, the difference between 1 and 2 is that 2 has slightly more options, more possibilities, more features that it supports. Level 0 is interesting because it specifies a level of functionality that can be met purely by static files. So you can pre-generate all the tiles, pre-generate the info.json file, and tell the browser exactly the very limited range of options that it can ask for. I only have tiles of this size and this quality and so on. And if the client is correctly configured, it will then only ask for those and use those to present the image to the user. So this allows for a very low level of technical commitment to get on the IIIF bandwagon. And I think that's really important. I've written a little Jekyll plugin for the static blogging system, Jekyll, that will let you throw high-res images in and get a level 0 IIIF presentation as part of your static blog. And it pretty much works. So, you're not limited at the presentation level. Sorry, okay, but you know, you can do quite a lot with that. So, is that 2 minutes covering the slight overrun we were going to allow by? Okay, then I got to hurry up here. Structure of a manifest. Sasha will show that. So here's a presentation, and I have a timer on my phone, but it is not, okay, I've been misreading that completely. So here's a presentation layer. This is a medieval manuscript in the library in Geneva. Nice book reader functionality. I can go to the pages I want. I can zoom in. I can get side-by-side page view. All this wonderful stuff. I can click on information and see that embedded metadata, which, as I said, is just simple name-value pairs. If I want to compare it with another manuscript. This client, this is the Mirador client, one of the two major ones, makes it easy for me to open two of them side by side. And if two isn't enough, I can get that many all side by side. So that application for scholarly use, for where you might well want to compare a large number of images and be able to zoom them all independently, is driving some of that. Back again. So from here, the far right, okay. All of this is driven by the shared canvas model, which again I won't go into detail on, but it's a specification which lets us describe each image as a canvas onto which we paint other things. And the things we paint onto it might be an image. That's the normal situation. The page image gets painted onto a canvas. But there might be more than one image we want to paint on. There might be text annotations we want to overlay or highlight. All of those count as annotations going onto a canvas. And this is very powerful in, again, extending the functionality. So this is to represent that at as an RDF graph. An annotation has a body, which is the content, might be an image, might be text, and a canvas that it applies to, and the position on that canvas where you want it to go. And I will demonstrate that. This is the highlight. All right, let me catch up with myself here. A medieval manuscript from which some creature that thought it was a human being cut out the miniatures. Quod anathema sit. But the miniatures ended up in another library, and they've digitized them. So we've got the original manuscript with holes, and in another library, another IIIF-enabled library, we've got the miniatures. So if I click that, it is restored. Not perfect, but so, yeah. So what's going on in the background there is that the manifest has two annotations on this canvas, one for the full image and then one for that particular part of the image where it's going to paint the miniature. It knows exactly those coordinates. It can point to two different tile servers to get the tiles to show those. So even though this could have been done without the cooperation of either of these source libraries, once they've gone IIIF, a third party can put things together, publish a manifest, and pull their tiles. So, yeah, I will wrap up if I can get back. Yeah. So the implications I wanted to point to are the fact that here's this wonderful service that we, in the old days, if we'd been doing this at Access 10 years ago, we would be talking about this as an application we could deploy on all our servers and get a wonderful service out of my repository, and you could borrow my code and get a wonderful service out of your repository. But now that we're taking it into the linked data world, into Rob Warren's ideal world, we have a responsibility to maintain the URIs that we're using as identifiers and the general structure of it, I think, beyond what we might have done as a simple application. If that URI is going to be useful, it's going to be useful as the basis of open annotations that other people are going to make. And they're going to serve them out of their annotation servers, which, as Rob said, could be triple servers that other libraries maintain. And if I reorganize our website next week and break all those URIs, then I've done a serious disservice to scholars. So we have a wonderful opportunity to be of great service to scholars by treating this as linked data, and we got to not drop that ball. And the reward, the reward, I guess, is the eye candy in the first instance, but in the future it will be linked data published as scholarly output that uses all these URIs that we're publishing, and we'll get really good stuff out of that. And with that, I will hand over to Sasha.